We have some basic properties for the mean or expected value, like E of the X. And we call it E of something like operator. For example, if our X is a constant, like C, like a number, like let's say it's 10 or 15. If C, like our variable it's a constant one, in that case, the expected value for that constant is going to be that constant, like expected value of 10 is going to be 10, right? And then we have the linearity of operator as well. So the expected value of the some constant times our variables of like X that is changing. In that case, we can put A outside the, like say that it's outside the X, and it would say it's equal to the A times expected value for X. So therefore, we can say if we are looking for the expected value of the some coefficient times variable X plus minus some other coefficient like B times variable Y, we can say, okay, it's equal to the A times expected value of X plus minus B times expected value of Y. Be careful, when you are looking at here, the expected value of X is the same as the mu for that variable of X, and then expected value of Y is going to be mu of that variable Y. We have the basic properties of the variance as well. Variance operator, you can write it var of X or V of X. I use all the time V of X. If it's for the population, it's going to be sigma. You would show it by sigma 2. If it's for the sample, you would show it by the S2. So variance of the, we want to do the same thing that we did for expected value for, like for mean, for the variance. And we say variable of variance of the A times X plus minus B times Y. Here, it's a different story, because we are talking about the variance, and variance is the deviation from the mean. If you write down the equation, if you write down the equation of the variance for this X and Y and want to expand it, you will see that it's not as simple as the equation that we have for mean. So what are we going to do is that we would say we have this equation for it. When we want to expand it, we would say it's going to be A2 A square variance of X plus B square variance of Y, and then plus minus 2AB covariance of X and Y. We have a situation that this covariance is 0. In that case, it's going to be variance for the variance of AX plus minus B of Y. We just simply will have A2 variance of X plus B2 variance of Y. So this formula is very important, and we use this one a lot in the formulation of our course. Like whenever we are working with the design of experiments, factorial designs, whenever we are dealing with these with different types of the variance, we use this equation a lot. So now what's the covariance of the X and Y? So this covariance of the X and Y, we are going to work on this more in chapter 2. We'll go through that over there. But let's say covariance, it's something, right? So it relates to random variable. So it relates variance of the variable X and variance of the variable like Y, or like we can say X1, X2, or Y1. It's just symbol in here, right, that we have, right, the name of it. But the covariance of X and Y is the expected value of the X minus mu for X times Y minus mu for Y. So it's the deviation of my X variable from its mean times deviation of the Y variable from its mean. So it's going to be we multiply that, and the expected value of that one is going to give us the covariance of X and Y. If X and Y, they are independent, meaning they don't have anything in like their variance, they don't have any thing like they won't affect each other. So that's independent, right? We would say. In that case, the covariance of X and Y is going to be 0. And so we would say, if we go back to the equation that we had for the, what would be the variable, let me go one, it's like this one. Think about the variance of ax plus minus by. If I'm thinking about the, if I say that x and y, they are independent from each other, so this one is going to be 0. So my variance of the ax plus minus by is going to be a square variance of x plus b square variance of y. So it doesn't matter that if I have like positive between ax and by or negative one. If they are independent, the answer is going to be the same, because this part is going to be 0. So one thing that we have here is like that. We can write it down like this. Let me just stop sharing. Here we can have that, for example, we said that if they are independent, right? So we said that in that case, their covariance is going to be 0. So the covariance of the x and y is going to be 0. So we can say the variance of the x plus minus y is going to be equal to the variance of x plus variance of y. So that's what we use if they are independent. And you're going to see that later when we are working on the experimental design, like the factorial design and those ones, we are going to use these assumptions a lot. So let's go back to our notes. And let's have a few more remarks. For the, when we wanted to add them, we would say that for the mean, we would expand it. But here, when we have multiplication of the expected value of the x times y, we can say that it's equal to the expected value of x and the expected value of y. The next thing is the population and sample that we want to talk about. For the population is the whole set. We talked about that a little at the beginning of this chapter. The whole set, a population is a reference set, is very large and can be hypothetical concept, including past, present, and the future production. Sample is the, we would say it should be unbiased data gathering from the population, and it's like that. You would say, you can see here that we have the sample size of like size n, for example. So it's like that we're going to get something from the population. It should be a fair representation of the population. Random sample is to make the inferences. We must describe or summarize the data in our sample. We make use of descriptors like indicators and matrices called sample statistics. The most commonly used that we have, they are mean, variance, as we talked about that. So if it's for the sample, what would we do is that we would show it by the x bar for mean, and if it's a population, we're going to show it by mu. Be careful with this one. I've seen a lot that over the past years, students, they make mistakes. It's just a typo, right? When we do a mistake like this, like we would say, we consider sigma or s. But like x bar and then s2, these are the equations that we would use for them. It's like for finding out the sample variance and mean, and we said that the standard deviation is the root square of the variance, and we can find it like that. So here, one thing that we can say here, look at here is, we said that S2 is that xi minus x bar power 2. So this one is, we call it sum of a square. We can say it's like the sum of a square divided by degree of freedom. We will talk about it more, but still we are in the second year stats. It's a basic statistics that we are covering. So you can see more details of these equations, that how can we prove it, in the second year note. Expected value for the S2, our expectation. Think it like in statistics, if we think about the concepts and learn the concept well, then a stat is going to be like piece of cake, in my opinion. But if we try to memorize it, we are going to face problem later. So here, look at it. It says E of S2 is like expected value of S2. So what should be the expect? S is for the sample and sigma is for the population. So our expected value for the sample variance is equal to the population variance, right? Makes sense. If variance of X is sigma 2, then the variance of mean is going to be sigma 2 divided by n. So this equation comes from the central limit theorem. Make sure that you're going to go and look at the central limit theorem in the notes that we have for the CHE 220. So it's like that we would say that, okay, so we can find out the variance of the mean. It's like that you have different samples, and each of them, they have, you're interested to compare the mean of different samples, right? So let's say I have a population, I get 10 different samples from my population, and then I'm interested to compare the mean of these different samples. In that case, the variance for the mean is going to be sigma 2 divided by n. N is the size of the sample. That's one thing that we want to consider while we're working. And then there are other things that we have is a coefficient of variation. We use the coefficient variation as well because it's free of the location. In fact, it's like that. Whatever sample standard deviation that you have, if you divide it by the mean, it's going to give you the coefficient of variation. So that we would say the percentage of the error is equal to the whatever coefficient of variation that you have multiplied by 100, it's going to give you the percentage of error. We have different types of the error. We have mean absolute error. We have mean absolute percentage error. So this one is another type of the error that we are going to work depending on the experiment that we are working and the data that we have. So we are going to choose these errors and work with them.